Mic check. Mic check 0 1. Mic check 0 1 because binary doesn't count to 2. Mic check 0 1, and especially featuring Chicken. How we doing? Yes. Yo, yo, yo. Mic check 0 1. Make sure everything is operational. Download the slides. You know, the lecture's motivational. We're learning C. It's like speaking a new language. Hop on the stream. You got plenty of friends to hang with. Yo, MCMC in the house. Literally in the house because we're not in a lecture theater. We're all in our own houses. In the house. How we doing, all? How we doing? 1511 rap. This is the first 1511 rap. And introducing DJ Chicken. DJ Chicken. Mixing not much in particular, but purring along while I'm rapping. Okay. As I said, I was going to spend more time preparing the rap than I did the lecture. That's not entirely true. I did also prepare the lecture. So, let's roll into it after that opening. Thank you, everyone. Although that did take me longer than it should have, and it wasn't freestyle. Like on Tuesday when I said I was freestyling, I was just sort of saying random stuff. But that time I was actually, like, I wrote that yesterday. Good morning, all. I hope everyone is enjoying what they're seeing so far of COMP1511 and programming. This week in new tutorials has been a sort of an advancement of what we're doing with programming and looking at things like if and else statements and how to use them, how to get a grip on the first sort of bit of maths that we've been doing. So I hope that if you've had your tutorial already, you've enjoyed it or at least got something out of that. If you haven't yet, hopefully there's something you will still get out of it. So let us launch into the lecture and see how we go. This is really funny. Actually, opening up with a rap like that has just spiked my energy. So I'm just like, yeah, let's do this. Okay. I mean, like, as opposed to normal when I'm usually a little bit, yeah, let's do this for every lecture anyway. Okay. So, what did we learn last? Now I'm doing the hands for everything. Yo, what did we learn last lecture? Everything. So last lecture was a little bit of a recap of all of the bits of C we've seen so far. But on top of that, we looked at problem solving. So we looked at what it means to think about many different ways that a problem can be solved. And I intentionally made the idea of solving problems something that can happen with many different possible implementations. So we're thinking about the idea that a problem can go away for many different reasons, and it's really about how you decide which one of those ways to make the problem go away is the one that you want to use. We're going to find this out the more work we do with computing and programming, is that programming has so many different possible ways to get the same thing done. I'm being vague about it because it really is vague. I'm talking about the whole field of programming here. Sometimes you will be restricted to what you can do because there's something important that we need to keep track of, but sometimes it's actually a matter of us wanting to try out different ideas and see which one is best for certain circumstances. So even when we were looking at what I was doing with the dice checker program, that was really keeping in mind what our original goal was a tool for a semi-random situation that a human was in. And so we accepted a solution that we would never accept in other situations. Like, we corrected the user's incorrect input and just made it into another number. A lot of the time when we're being really specific about things, we would never want to do that, right? But it was okay in this situation. So I wanted to show you how problem solving is not a matter of a single answer to every problem. It's that every problem has multiple answers, and choosing the right one involves thinking really carefully about why you are solving the problem. So hopefully that, and the idea that every problem we're going to break down into its parts and solve piece by piece, that kind of thing is the attitude that you can carry forth into a lot more of your programming. Um, Miguel wants me to do a rap at the start of every lecture. We'll see. We'll see how long it takes before I run out of ideas for those. But I thought after I mentioned it last week that I should just do one at least. Okay, so other actual sort of C techniques that we worked on last week, we learnt about if and else statements. We should be getting pretty solid with those. We're going to continue with them today. In fact, it's going to be hard for us to write any programs for the rest of the term without using them. Because as you can see, our programs become very, very similar, running exactly the same way if they don't have any branching code in them. I mean, it's one of the things that really makes computers better than a simple tool is that they can change, they can react to a situation as they see it. I mean, we're not really at artificial intelligence yet or anything like that, but we're getting to the point where the computer can react to the environment it finds itself in. We used hash-defined constants. We also used modulus that we hadn't used previously. And also some use of relational and logical operators. So the first time when I introduced what those were, I didn't really pile on all that content at once. So we didn't really use the logical operators to join questions together until last lecture. Thomas is offering to write the raps for me. So if anyone has rhymes that you want me to drop in the lectures, you can. I don't have a special email address set aside for rhymes or anything. Maybe you can put rhymes in the in the course forum and tell Dean, who is like Dean and Tammy, who are managing the course forum. You can tell them to pass the raps on to me or something. Um, I was thinking of actually writing some beats as well because I actually used to do that back in the day. Anyway, what are we covering today? We are adding one new concept today, and we're going to spend the whole lecture on this one concept because it's really, really fundamental to a whole lot of programming, and that's looping. So up until now, our code has run top to bottom, and our code may have turned stuff on or off. Jonathan, your sending an email address is usually hidden by whatchamacallit, by YouTube Live. Although I probably shouldn't have let that one through because now someone's going to send to that and that message, that email address is just going to bounce. Okay, so we're going to show you a particular type of loop called a while loop. If you've done other programming before, you may have seen other types of loops. I am using only one type of loop in COMP1511 because this particular kind of loop can stand in for all other possible loops that can happen in programming. So I'm teaching this in such a way that people can have one tool that will do everything that we need in the course, rather than teaching multiple different ways of doing it. So some of you may know other ways of using loops. A very famous one is one called a for loop. You can use them if you want to in the course, but we won't be teaching them specifically. And there are reasons why. The while loop is really, I think, one of the best ones to learn because it goes top to bottom. You can actually read it line by line and understand exactly what it does. So that's why I'm going to be using those. Also, there's nothing, I think maybe there might be one subtle case, but there's nearly nothing that a while loop can't do that any other loop can do. So looping code is code that's going to run again and again and again. So when it finishes what it's doing, it's going to go back and then it's going to be able to do things again. We're going to look at how to start loops, how to stop loops, how to write them, and then we're going to look at some interesting things we can do with loops. I have an example to work on today, which is actually a continuation of these dice-based programs that we've been doing the last couple of lectures. So this one is going to be a program that looks at all of the possibilities that dice can roll and what we can do with them. So, as I was saying a second ago, sorry, my face is nearly covering up the letters. I'm just going to move that a little so I'm not. Line by line, C usually goes from the first line after int main, and then just goes down the list and executes each one of those instructions in order. At most, we've been able to turn on or off those sections by running an if statement and saying, okay, some of this code will run, other code doesn't run, but we've had no way to jump back to previous code. And if we wanted to run the same code more than once, exactly the same code more than once, if we wanted to, we can just copy the code and paste it below, then copy the code and paste it below and stuff. But that's really, really kind of infeasible. That will lead us down a dark pathway of having these massive, massive code files that we can't read anymore. So we don't really want to do that. We want to be able to have a small amount of code that runs a lot. That makes it easier for us. It makes it easier for other people working with us to read what we're doing and understand what we're doing. Okay, so this is the actual code for a while loop, and it will look really familiar because the syntax, so the actual kind of grammar of the while loop, is identical to that of an if statement. The only difference is it has the keyword while instead of if. So someone said cries in Word Edition. Someone said 150 lines for Word Edition. At some point I will talk to you about Word Edition, because there are ways to reduce Word Edition down to, I think, I don't know, Shrey, if you remember this correctly. Shrey's in there. How's it going? 11 if statements? 11 or 12 if statements? But I won't talk about that just yet. If I'm going to talk about stuff in the tutorials, I think I will spend time talking about it maybe the week after or something. Or if people want to stick around afterwards today and ask some questions, I can potentially talk about it. Okay, so talking about the while loop here. Format is very similar to an if statement, which means it actually has some of the same functions as an if statement. We have an expression here inside the normal brackets. And inside the normal brackets is a question. This is the same as the if statement, and there's a question there that may have some true false 0 1 response. Actually, not 0 1, 0 or any other number response. And this will be checked. If this is true, then what's inside the curly brackets will run. So what I've just explained there is exactly the same as an if statement. If this expression is true, what's inside these curly brackets will run. The only difference is when we hit the end. So when we hit the end and the while loop finishes, well, I shouldn't say loop yet. When this body of code here is run and finished, an if statement will just move on to the next bit of code. So it will finish what it's doing and moves on. The while loop instead jumps back up to the while and checks the expression again. So the difference between the while loop and the if statement is the if statement runs once and moves on, whereas the while loop, if it ran successfully, will always come back and check the expression again, which means it will keep running again and again and again until this expression is not true. So the trick there is this expression is our way of checking whether the loop should run again, which means it's also our way of ending the loop if we have to. So if the loop goes to a certain point and ends, the expression is how we know whether it ends or not. And so all the detail in the comments here is saying that. So yeah, now that we know if statements, the while loop runs reasonably similar. The only difference is it decides to jump back every time it reaches the end of the code that it runs. People are asking questions, about challenge exercises and stuff. Yeah, you don't always have to do the challenge exercises, but you can learn some interesting things from them. A lot of the challenge exercises, I should talk about this because people are asking about it there. A lot of the challenge exercises in labs are not core learning. So they're not necessary to understand the concepts of what we're doing, but they will teach you something about the ongoing ramifications of something. They will teach you something about what is the continuing thinking about some of the concepts that we're doing, or they will challenge whether you can use these things in a way that you didn't expect as well. So there's other little tricks like that. Okay, so I think this slide is actually what I was just talking about there, but it was better for me to talk about it during the slide. But this slide will be here for reference if anyone needs it. So yes. Yeah, this is exactly what I was talking about. So this is in text what I was talking about when I was explaining how the while loop works. So there's a few different things that we need to do. Get my face out of the way of the words there. Um, we can do two different things with those expressions. So I'm going to teach you two ways that we generally use while loops. There are always other ways to do it. There's other interesting things to do, but I'm going to teach you two simple ways to do it to be our first kind of foray into while loops. One of them is a loop that definitely runs a specific number of times. So we use an integer to count how many times the loop has run, and then once it's run a certain number of times, we say, okay, stop, you're finished. So this is what we're going to be calling a loop counter. This is a really, really standard while loop that is probably the most common way the while loop is going to be used. The second way the while loop is going to be used that we're going to learn about has this thing called a sentinel. It's not something that attacks mutants. This is a variable that we use, and all that variable is there for is to decide whether or not the loop should continue or not. So it's basically an on-off switch. So you can say keep looping until something happens, and then when the right thing or the wrong thing happens, we flip that switch, and that switch is going to change whether the expression is true or false, and then the loop will end. So we have two ways, one that loops an exact number of times, and one that loops until a condition. So this one that loops until a condition could technically run forever, but not necessarily, but maybe. Actually, now that I think about it, let me just make sure I've got my examples here, because I'm going to show you a couple of these things, might even show you some of them running, which means I will take our demo code. Oh, that's the wrong term. So where are we? Week 2, code looping demos. So these are the demos that you can always download from WebCMS if you need. I'll just put them in the COMP1511 directory. Alright, so now that I've saved that, CD, change directory to COMP1511. Have a look in here, I've got my loop demo. I want to start a directory for lecture 4, so I'm going to go mkdir, make directory, lecture 4. And then I want to move the loop demo file into lecture 4, so I'm going to go mv for move loop demo. I press tab then to auto-complete the file. I'm stepping you through everything that I'm doing here in the Linux terminal to try to get you more familiarity about how to use it. So mv is going to move a file. I have to say where it came from, which is this file, and I say where I want it to be. I want it to go into the lecture 4 directory. Press enter there. If I do my directory listing now, I've made the new directory lecture 4, which is now appearing. I've moved the file into there, so the loop demo no longer appears at this level. And if I go into lecture 4, look in here, loop demo's in here. Gedit, this same line is what we're going to be using a lot of the time to open our files. And I've got a bunch of loop examples in here, so I won't dive too much into these just yet, but I just want to have that open so I can go back and forth and show you some of these things running as I'm talking about them. Okay, so this is our first one. Our first one is a loop with a counter. So I have an integer here. I've called it counter. It's not always going to be called counter. Sometimes it's going to be called something specific to what it's counting. Sometimes we shorthand this with just the letter I, which is known as an iterator. So this is one of those few times where a single letter variable name is sort of accepted because we have a convention in the programming world that we understand that I is usually an iterator that's inside a loop. So I have set up this number. This number starts at 0. Then when I go into this loop here, the counter is less than 10. This will be true the first time because the counter is 0 and 0 is less than 10. And then I've got this printf here that just says we have looped a certain number of times. So this will help us because if we run this, this thing will tell us how many times it's run. So the first time it'll say I've run 0 times because it hasn't finished a loop yet. And you can also think of this always as being what the counter is actually telling you. If you start from 0, the counter will tell you how many times it's completed its loop. If you start from 1, you can say, I guess you could say that's how many times we've entered the loop. But we tend to start counting in programming from 0. As you saw from the mic check at the beginning of the lecture today, mic check 0, 1. We start counting from 0. I will tell you more about the kind of deep specifics of why we count from 0 later on when we get to that, because there's a lot in computing that we start counting from zeros a lot of the time, but when we know more about memory and how we use memory and lay it out, I'll show you why we count from 0. But for now, just take my word from it. We're usually going to start counting from 0. And the nice thing about it is in the while loop, when we're in the while loop, the counter will tell me how many completed loops we've had. So when we're in it the first time, we've had 0 completed loops, and then we have this at the end of each loop that says counter equals counter plus 1. This is going to add 1 to the counter. So when we finish this loop, the counter will be equal to 1, and we'll go in again and it'll say, okay, we've previously run this once. Counter will be less than 10 again. We will enter it again. We will print out that we've looped 1 time before. This will keep going until counter equals 10. When counter equals 10, this expression will no longer be true. When this expression is no longer true, then the while loop will exit and it will go on to other things. Let me show you this working. What I'm going to do is just comment out the rest of the examples so we can look at them one at a time. So this is the first basic loop. It's the same thing, counter equals 0. The message isn't exactly the same, but it's giving us the same information. It's just saying the first loop has completed a certain number of times, and then counter equals counter plus 1. So I'm going to save this, Control S. Then I'm going to compile this using DCC. So DCC requires the file that we're going to compile from, so the file that we've written code in. And if we want to, we can say what the output file is, which I'm going to do, called loop demo. And then I'll run loop demo. So now we see our capability, our first capability to write repeated code. We are completing the loop, and the first time the loop has completed 0 times because it's in its first run, and then it's completed 9 times. And then when it tries to, when counter is equal to 10, and it tries to come in here, it will then stop and it will say, I cannot run any more times because my counter is now equal to 10, which fails this condition, and then it exits the while loop. And then it continues on with the rest of the program at the moment, which is just return 0. Check how we're doing. Looks like Shrey's answering all our questions there. Yeah, I think that's fine. I think Rosie was asking about whether you're missing out on anything if you're not using gedit versus VS Code. Not necessarily, because gedit is a text editor. Basically, everything that you can see the gedit can do is the text, changing the text in this window, and VS Code's capable of doing the same stuff. Okay, so that's our first kind of loop. It's a good loop because we can control exactly how it works. So for example, if I say I want this to run exactly 5 times, I just changed the limit of the counter to 5. I'm going to compile and run this. And it goes through 5 times there. So when we want to do something a specific number of times, this loop's really good. All we do is set up a variable outside the loop to say how many, to count how many times it's going, and then we set a limit in the question there. Okay. One thing. I didn't realize this was going to be such a musical lecture because I'd forgotten that I had this slide in there. The following while loop will run forever. So one thing that we must think about any time that we are going to write repeating code, we have to make sure we know how it stops. If you don't know how code stops, then you can't guarantee that it will stop. And if it doesn't, it could go on forever. So let's try this second example here. I'm going to comment out the first one. And I'll comment out the last one as well, because we won't look at those yet. And yes, you did get rickrolled by your lecturer. And I'm going to uncomment this special second one here. I might actually put some code in here. You know what I'm going to do? I'm going to change this to a printf. Grab this, cut Control X, Control V on this. And I'll do a printf for this one as well. Okay, so people are saying this is going to blow up your computer. It won't necessarily blow up your computer, but let's have a look at what this actually does. So I'll save this and compile my lecture rickroll, and I will run loop demo. Uh-oh. This is never giving me up, and it's never going to let me down. This is potentially going to run forever, until maybe I get an email from our system services people saying, Mark, you have a program that's been running since the first time you taught COMP1511. Are you sure you need this one little program to be going forever? Because it appears to still be running. I don't know if they'd even notice, but possibly. So let me tell you something that that will come in really handy once you're learning about looping, because you can quite easily get into this situation where this thing looks like it's going to go forever and you can't stop it. So the way that we're going to stop this is the same way that we can actually stop any of our C programs from running while they're running, is I'm going to press Control C. So Control C, and this will stop. So Control C will stop the execution of a particular program, but what's even better, because of how DCC works with things, it's actually going to tell us where we were in the program when we stopped. So it says stopped in loopdemo.c at line 27. So I can say line 27 here, and I know that I was inside this loop on this line when it stopped. So that way, if I get a loop that runs forever and I had multiple different loops in our program, DCC should tell me where exactly that was. So remember this. If you get a program that's looping forever, Control C is going to tell you when to stop. So hold Control, press C on your keyboard. Oh, I should also point out, Shrey's asked me to explain what a rickroll is. If you've never heard this, there's a song by a guy named Rick Astley. Is it actually called Never Gonna Give You Up? I can't remember the name of the song, but it's got the lines in it: never gonna give you up, never gonna let you down, never gonna turn around and desert you, and all this kind of stuff. And it's like, it's just, it turned into this big internet thing where people would pretend they were going to show someone something useful, and instead they just showed them that video of Rick Astley singing that song over and over and over again. So that was my little quote to that little joke in the slides there. So Just remember that Control C. Control C is going to get you out of these things, especially now that we're looping. We're definitely, while we're looping and we're still learning how to make these things work, we're definitely going to get in situations where they go forever. So Control C will stop it and will tell you where it was. So if, for example, like in this program, I have multiple different loops, I will be able to figure out which of these loops I had a problem with. And then this one, the problem is reasonably obvious because this condition is always going to be true. There are many other ways we can do that by accident that are more subtle. So we'll see them as we go along. You will probably see them whether you like it or not. One of the most common ways to do that is to say forget this line. So if I forget to change the counter, my loop will go forever because the counter is 0, and if it never changes from 0, so we never run this line, it's never going to hit 5. So that's one way we can accidentally make a loop that goes forever. Alright, I'm going to comment out this loop again because we don't want that in our demos while we're trying to look at other things. Okay. Shrey's actually giving you the link to to how to rickroll. Yeah. In general, links won't appear in live chat if you try to send them because we've got just the basic spam protections on as part of the YouTube live thing. Not that we don't know we very often get people turning up in the live chat who aren't actual students, but because the link on WebCMS is technically public, other people can join in. Okay, so let's continue. But I think that one thing to always remember is if you're going to create a loop, the first thing that you think about, even before thinking about how many times you want it to run or anything, is think about how you're going to stop it. And then, once you know how you're going to stop it, then you can build the rest of the loop. Okay, another thing that we can do is we can use this thing called a Sentinel variable. Don't worry too much about all this code here. A lot of this code here is just other stuff going on. The key elements of this code are I'm using an integer because it's one of the only variable types that we have at the moment, but I can have this thing saying end loop, and I can set it to 0, and so I can say this loop will end if this thing becomes anything other than 0. So while I'm running this, I'm just saying if end loop is still 0, so if I haven't been told to end the loop, continue running the loop. So we'll run the loop, and what this one does is it says type in a number and then scans in a number. So we've seen this before, right? We've seen this in our previous examples. If we need to read in a number from our user from the terminal, we use scanf. Then we have an if-else statement here that's saying, is the number even or odd? So I've used a modulus here, and the modulus is saying, if dividing it by 2 gives a remainder of 0, that means it's even. We'll print out the number as even. And then this thing's going to keep running if the number's even, except if the number's odd, it's going to switch end loop. It's going to say the loop should end now. And if end loop equals 1, the next time it comes back to this check. So it's going to keep looping around every time you run it. And if it's even, it will keep going. If it's odd, it will go to there and it will say, okay, the end loop Sentinel variable was now a 1. So if it's a 1, the loop will stop. So this loop could potentially run forever, just like the rickroll loop, but it's unlikely to run forever because at some point we're probably going to type in the correct response that's going to make the loop end. Rosie's asking a good question there. Do we still have to use a descriptive name for counter integers? And it depends on what they're counting. So if, for example, actually, as we're going to do later today, if we're counting through dice values, then yes, we would say, okay, these are the dice values that we're counting through. But if we're saying we have a series of information, and what we're doing is we're just moving along that information and checking each of them, we'll often use something else. We'll use something like just I or something. If I have a variable that's determining whether the loop is going to continue running or not, I would put a good name on that. Like this name is reasonably good because we don't really have any information about this loop. This name is saying, do I end the loop? If I end the loop, if I say 0 for end the loop, say don't end the loop. If I say 1 for end the loop, it means end the loop. So what I've done is I've chosen a variable name there that makes sense for the fact that this variable is deciding whether the loop ends or not. So you can kind of decide how you're going to name things like that. Yeah, and Miguel's also saying we could actually do this in more detail where we didn't even have to ask this question here. Let me actually show you in code. I like it when people have little suggestions for things that we can do with our code, because then I can come in here and I can show you different things. So what I'm going to do is just comment out everything else except for this last example. Oh no, there's another example after that. I'll comment out the last one as well. Okay, so this is the example where you're talking about here, using a variable to exit a loop. So let's just run this for now so you can actually see this thing looping and what it's doing. So I've commented out everything else and saved it. So now compile with DCC. That creates the program loop demo. Now I will run the program loop demo. And says, please type in a number. And as we know from the code here, it's going to be looking at even and odd numbers. So let's type in some even numbers. Every time there's an even number, it loops back around. And I'm going to type in an odd number now to see if it finishes. Number is odd, program exits. So the trigger for ending the loop was the input number mod 2. So remember, mod is what is the result if we divide this number by this number. So if we divide it by 2 and it has no remainder, it's even. If it does have a remainder, it goes to this else. And you know what? I should probably, what I do often, what I do often is I put a comment in here to say what it is, and I realized why I didn't have the comment, because I've got this here and this here. It's exactly the same words. Okay, that's why. But often when I put an else statement, I will still put a comment in the else statement to remind myself, especially if we've got lots of if-elses and things, it's nice to know what it actually meant if it reached the else. And I realize now why I didn't put the comment number as odd there, because I actually had those exact words afterwards, so I'm just going to leave that out. So when the number was odd, end loop gets set to 1. Remember, single equals is to change the value of a variable. So it's to assign this value to this variable. Double equals is to question whether this variable is the same as this variable. So just remember that difference. If I set end loop equal to 1, we'll come up here and we'll fail this check. And if we fail this check, the while loop won't run again. So the while loop acts very much like an if statement there. So who was saying that? I know someone was saying that. Was it Miguel? Yeah, Miguel was saying there's an interesting thing that we can do with this is we don't actually need a relational operator here if we were going to do this a different way. So I could actually just check end loop, because end loop has a numerical value. And remember, everything I said about numerical values is that true is any number other than 0, false is the number 0. So if I flip this, I could do something like this. I'm going to change the name of the variable now because it no longer makes sense. I'm going to call it run loop. Because I'm using the opposite ones and zeros this time. So run loop equals 1, saying run the loop if this is 1. And now we don't actually need an equals in here because run loop is its own true false value. So run loop says keep running if I'm 1, and then if I become 0, I'm saying stop the loop. So this is another way that we can do this, which is maybe a little bit more concise than before. I'll put it back the way it was, just because, actually no, I'm just going to leave it like that. So there's two options here. There's this way that we could do it, or there's the way that I did in the slides, just because I wanted to show you again like things like the relational operators and things like that. So this loop is useful because what you can do is you can say, potentially, if we keep getting the right answers, we'll just keep running this thing forever. Otherwise, if we don't get the right answers, we will end the loop. Note, and I think someone was talking about this in chat, I just sort of scanned it. Rosie's saying, can loops be used for passwords? Like, would you keep accepting inputs until the correct password is written? Yes, you could definitely do the same thing here. And I think someone was saying about the dice checker. Yeah, Miguel's saying about the dice checker. Exactly. We could do the same thing. So last week we were saying, what do we do? Could we force the user to keep typing in dice roll numbers until they were valid? Now we have some code that would allow us to do that. So now there's like a retrospective challenge. I could say you could go back to last lecture and you could add code to the last lecture to make it keep running while the inputs were invalid up until a valid input gets entered. So we could actually change our solution to the problem now that we have more tools to play with to do it. Yeah. Gira-chan saying comments next to ending brackets. You mean comments here? I have a feeling that's thing. Actually, let's talk about this outside, because I think that when we're talking about specific style of where we want to put things, we'll talk about that in its own lecture. I don't want to confuse too much by switching topics mid-lecture. But Gira-chan, we can talk about this afterwards, although you probably don't want to stay late most of the time because you need to sleep. But have a chat with your tutor about it, and we'll have a look about exactly how that works. Rosie was double-checking something. While run loop is correct, so if run loop equals 1, it means the expression is true. Yes, you are correct, Rosie. So this one, it will always run the first time, because run loop is always 1 to begin with, which is a true value. And only if we see an odd number will run loop get turned off. And if run loop is get turned off, the loop gets turned off, like that. Okay, so that's our Sentinel variable. That is our ability to run the loop a non-specified number of times, but stop under a certain condition. So the difference between these two, this one says I run a specific number of times, and I control that because every time I run, I count how many times I've run, and then I will end. This, oops, not this one. This one says I don't know how many times I'm going to run, but every time I run, I will potentially say this was the last time that I was going to run. So either I do this and I don't make any changes and I say that wasn't the last time I was going to run, let's do it again. Or I say that was the last time I was running, let's finish here. So these are two simple ways that we can do things to say that we need to run something a certain number of times, or we're going to stop at a specific point. Now, get my face out of the way of that one. I heard you like loops, so I put a loop inside your loop so you can loop while you loop. Now let's think about this. When I ran a loop, I opened some curly brackets. And if I open some curly brackets, it means I can put some code in there. If I want to put some code in there, it could be another loop. So if it's going to be another loop, that means that every time one loop runs, another loop that can be inside another loop, and it can run many, many times if you put a loop inside a loop. We're going to look at these because these are actually really important. To be able to do this is quite important. In fact, I'm just going to drop a hint. Your first assignment is definitely going to involve using some loops inside loops, as well as other things we're going to teach you. Don't worry too much. The first assignment is still a week and a bit away before it's even released, and then there'll be 3 weeks worth of working time on it. So you'll know more by the time you get into this. But I am going to teach you about looping inside loops today because I think it's important that we know how to do that. I'll build it up though. So we have a loop within a loop here, but what I'm going to do is actually build this up piece by piece. So I will extend this comment to here and then work on this final example. You know what I'm going to do though? I'm actually just going to comment out the whole example first, and we're going to build it up piece by piece. Let me start off with, I would like to draw a row of asterisks, a row of stars on my terminal. So how would I draw a row of stars? Draw a row of stars. So what I would do is I would say, let's loop for how many stars we want to. So let's say, for example, I want 10 stars. So draw a row of 10 stars. So I'm going to need an int that says how many stars we've got. We're going to call that stars is equal to 0. And then I'm going to make my while loop. So in order to make my while loop, if I say I'm going to do a normal loop that that goes 10 times, first thing I'm going to say is, how do I make this end? I'm going to end when stars is 10, which means I will run every time stars is less than 10. So I don't in this question say what finishes the loop, but what I say is what's the condition that we keep running the loop. So if I want it to run up until 10, that means I want it to run for all the values less than 10. Assuming here that I start at 0, if I wanted 10 stars and I was starting at a different number, then I would have to change my conditions. So if I said, if I'm starting at 10, then maybe I'd go to 20. But for the moment, to keep this thing simple and so I can keep track of what I'm doing, I keep it like this. Another thing that I like to do is usually put a comment here saying loop has run stars times. What this does is it reminds me, if I'm reading this, that I know that every time this loop runs, I know exactly how many times it's run before, and I know that this variable is tracking how many times it's run. So if I am printing a row of stars, I would then do something simple. Printf a star. This is going to print 10 stars in a row, although I probably shouldn't have done that, because I should be careful to construct the loop before I put the stuff in it. So I was risking this loop going forever because I wasn't what we call incrementing, adding one to the stars. So the mechanical bits of the loop are set up the number, know how it stops, and then make sure it continues each time. So what this is going to do is print out a row of 10 stars. In order to end that row, I will probably put an end line on this. Okay, so I've saved that. Let me compile that and run that, and you'll see I can print out 10 stars. So the nice thing is, because I'm running looping code, I only write one printf, but my program will run that printf multiple times. So I'm using my up and down arrows here to access my previous previous command. So that was my DCC command for compilation, creates the program. Then my running of the program is the // and the program's name. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Printed the correct number of stars. Okay, so that's my single loop. I've got my single loop there. Some random guy. I do have a slide for that later, so wait for it. I actually do want to talk about that syntax for it in a second. So, spoiler alert, I will talk about that in a moment. Okay, so I have done a single loop there. So what if I want to change this now, and I don't want to just draw one line of stars, but I want to draw a whole grid of multiple stars. So I want to draw multiple lines of stars. So if I want to draw multiple lines of stars, then I would want to run the code that draws this single line multiple times. So if I want to run the code that draws a single line multiple times, I will put that in a loop so that it goes multiple lines. So I will take this whole thing and I will say, okay, I want this whole thing to run 10 times, which is not that hard. So I'm going to say run the drawing line code 10 times. So if I want to run something 10 times, I could just say in lines is 0, set up my while loop. How does my while loop finish? It runs up until 10. Oops, lines equal lines plus 1. So this is definitely going to run 10 times. It's going to record how many times it's run using this variable lines. And we know that it has run lines number of times. So then what I'm going to do is I'm going to say the functional code inside this while loop is going to be this chunk of code. This chunk of code draws a single line, and then this single line is going to run 10 times. So I'm going to cut this with Control X, then Control V to paste this in here. Secret tip for those using gedit, although I'm pretty sure this works in VS Code as well. If I want to indent a bunch of stuff at once, I can hold down Shift. Oops, sorry. Shift tab goes backwards. I can tab while I've selected a bunch of things and will indent it. If I press Shift tab, it goes backwards. So this way, I can control the indentation of a whole bunch of code. So when I put code inside other code, I can shift it to the right indentation. So now that I've got it selected, I can press tab and it indents further, and Shift tab unindents and takes it back. So I like to have my stuff when it's inside another set of curly brackets. I like to have it indented inside. That way I can see clearly what's inside and what's not inside. Oh, Guru-chan saying Shift Option F. I apologize to Mac users. I have spent years working in OS X, but it's definitely not my native operating system. So I will, I know Windows very well, and I know Linux okay, but Mac I know even less. So it's helpful, I think, if you're running a Mac to watch comments to see if other people have help there. Okay, so what we've done here is I've run one loop 10 times, and inside that loop I put some other code that I wanted to run. Importantly, part of that code that I wanted to run was another loop, but you can kind of think of it that way, where we could write one and then we can build it up by running the whole thing. Wait, is Guru-chan trolling everyone? Formats the whole document. Oh, Miguel's saying Control plus square bracket. Oh, controls the square brackets either way to change the amount of indentation. Cool. All right. So if I was to run this now, what I'm going to get is this loop runs 10 times, and every time this loop runs inside it, which means I should get 10 lines, each of them with 10 stars in it. And the cool thing is, I have only written printf once in my code, but my program's actually going to run it 100 times, 10 by 10. So let's save this, compile this, and then run it. Hey, there we go. Oh, wait, no, it's not troll. It auto-indents the document based on the code. Right, okay, good. I get it. Sorry, Guru-chan. Thank you. Okay, so what my code here has done is it had code to draw a single line of stars. It will do that, and we could see that running on its own. And then if we wanted to draw multiple lines, we put a loop around that, and we get that to run multiple times. So, for example, that dice check app that we had before, we could just put this giant loop around it, saying, okay, all this code could run multiple times, and then you could have some part of that saying, okay, we try to take input, and then whether we run again was based on whether that initial input was valid or not. So you could do this kind of thing where you take code you've written before and you say, okay, put a loop around it, and then figure out how that loop around it's going to work. So that's going to be pretty much the same as what we had here. But what I might do is I'm just going to delete this, because that's the demo code that you can download. So I've got two versions of the demo code. One that you could download previously and the one that we worked through here. So I'll just save that there. So that is our first look at how we put a loop inside a loop. When we think about it carefully, a loop is just a section of code that does something. So we don't really have to think, we don't have to bend our brain too much around this idea of two-dimensional looping and stuff. And like when you get down to it, you put another one in there, and then we're three-dimensional looping, and then you can do four-dimensional looping, and then your brain explodes, right? So just be careful with that. But when we're doing something like two-dimensional looping, we can think of it as I run some code that does something. How many times do I want to run that code? So instead of me thinking I need a 10 by 10 thing and getting really complicated, I can say I need some code to make a row, and then I need some code to make that row run multiple times. And then it's easier to think about how to wrap your head around the multi-dimensional running and that kind of thing. Dan was asking about, oh, you thought that it would just keep going down with a single line of stars. I've been careful about where I put the new lines, which I think is what Girichan was saying there. So this while loop gets to run all 10 before any new lines get printed, which is why they're all next to each other. And then after 10 are printed, there's one new line. So the code to draw a single line says it will end that line going down to the next line, and then it will run again, and it will start here. Then it will print out another 10, and then it will press the enter key, and it goes down to the next one, right? So I've chosen exactly where the enter keys are going to be, so that we get a line. Okay, so there's one example of a loop within a loop. We're going to be looking at this kind of thing again as well. So there's the grid of stars. One thing that I also want to talk about a little bit. Oh, hang on. There was a question there about indentation. Anthony Bertuka is saying, why isn't the second loop indented a second time to differentiate from lines 64 and 65? Let's have a quick look. 64 and 65. So we're thinking about this code was the code we wrote to go once, and then it's inside this loop, and we consider this line to be part of this loop. So the trick there is the subtlety between what is running inside the loop and what isn't. So all the code that is running inside the while loop is indented once. So this code, even though it's not part of our original section to do something, it's running at the same level as it. So this code runs once every time this thing loops. This line also runs once every time the while loop runs. So it's actually now part of the same body of code, where everything that's indented once in here says, I will run every time this line's while loop runs. So this kind of becomes a little bit indistinguishable from this bit of code. If we want to, we can just put a space in between them to show that this is one paragraph of code, this is like another sentence of code, but they actually run at the same level because they run the same number of times. Yeah, cool. I think I answered the question there. All right. So let me talk about the curly brackets. And here's my my hilarious, what they call the Vegas rule of curly brackets. What goes on inside the curly brackets stays inside the curly brackets. Sorry, I called them braces here. What goes on inside the curly braces stays inside the curly braces. So the interesting thing to think about is that anything that we create inside a set of curly brackets will only ever last as long as what's inside the curly brackets. Anything that we create outside of the curly brackets will last through those curly brackets, but will stay afterwards. So a good example of where this is working is this here. So the variable stars was created inside this set of curly brackets. And this is a thing in programming that we call scope. Scope means that certain things only last for a certain amount of time. For example, all of the code that we've written in our program is inside a set of curly brackets here, which is our main. Once our main finishes, all our variables disappear. Everything that we ran disappeared. The only thing we have left is say what we've written to the terminal or something like that. Once the program finishes, it wipes itself clean. You know, it's done. The interesting thing is everything inside a set of curly brackets also does the same thing. So this variable stars that I created to be part of this loop here, I'll show you something interesting. Stars is an integer. So I'm just doing a really generic printf statement to say, let's print out the value of the variable stars. And I know it's a variable because I've made it here. So let's see if we can print it out. If you know, you know. So let's try to compile this and see what it tells me. Oh, error. Use of undeclared identifier stars. By undeclared identifier, the compiler means you've used a name stars which hasn't been defined. If it was a variable, make sure you declare it and check that it's spelled correctly. So DCC is trying to tell us, I'm trying to use a variable that doesn't exist here, stars. And it's like, wait up. It exists right here. We created it. The trick is scope and these curly brackets. If I create something inside the curly brackets, easy rule to remember, what goes on inside the curly brackets stays inside the curly brackets. Once we hit the end of the curly brackets in which this was created, it will forget that it existed. And so here, when I'm saying use the variable stars, my computer is saying, I don't know what stars is. I've already forgotten that. So one thing to remember is if you want something to last longer than one loop through, i.e. my lines number is tracking how many times the loop has run, it must be outside the loop to be able to exist every time I want to check it. If I was to put it inside the loop, every time I checked it, it wouldn't exist anymore, like stars doesn't exist outside the loop. But anything that I only want to exist for one loop through, so this stars is only used in here. I don't want it to exist outside because it's only used for the code that's inside the loop. That's why it's declared inside the loop. So that's a little bit about program scope. We will look more at how scope works when we start using a whole bunch of these in different parts of our code. That's in something we call functions that we're going to look into later. Yeah. So let's come back to here. So the curly braces are going to kind of declare which sections of the code are their own self-contained mini programs. It's not really a different program, but it's a mini section that says, I make my own variables, and when I finish, they go away again. So you will see that sometimes things need to be inside sets of curly brackets, and some things need to be outside. Matter of practice again. You will get practice with this kind of thing as you go along. Summer is asking, can you use the same variable name for variables in different sets of curly brackets? Yes, you can technically. The program will deal with it, but can you deal with it as a human? Because I can't. If I start doing that, I'm going to get it wrong. Because humans see context in a different way. We don't pay attention to scope quite as well as computers do. So just be careful. In general, be careful with everything. So, about to go into break. So, what I said earlier about putting a loop inside a loop is that everything that we write, sections of code, statements of code, expressions and things like that, they're all code. So we can put if statements inside while loops. We can put while loops inside if statements. We can put while loops, inside if statements, inside while loops, inside if statements, inside an else statement from another if statement, etc., etc., etc. It's possible. And I say it's possible, but it's not necessarily a good thing to do. So the thing that you want to watch out for when you put too many things inside each other is humans hit a limit. We hit a limit on what we can understand and what we can read. And that's nearly just as important as whether the computer can understand it. The computer can always understand it, but if we can't, it's really, really hard for us to know whether we're doing the right thing or not. So just be careful the more stuff you put inside each other. The 1511 style checker that we have will remind you that there's a problem. So when you get to like four, I think 4 or 5 levels of things inside each other, it will say, we think you've got a problem here. And that doesn't mean that the code won't work. It'll mean that you may not understand what it does, which means you can't edit it and things like that. Yeah. Um, okay, so let's go on break. It's 12:05 now. We'll come back at 10 past 12. Um, I have a video to show you here from one of the university's programs. Usually we'd have people come into the lectures and just grab the microphone and talk to you, but in this online day and age, I have to do the difficult thing and ask people to send me videos if they want to talk to you. But I've got one here today to show you, which I will do during the break. Okay, let me just switch to the thing that will do that, and we'll come back to the actual lecture at 10 past 12. Oops. Where is it? There it is, and I'll make sure the audio is on and mine.
Hello, everyone. Thanks for having me with you today to talk about the Challenge program. My name is Kevin Newcat, Project Officer in the Student Opportunities team here at UNSW Engineering. The Challenge program is an Australian-first initiative that prepares you for your future career by providing a multidisciplinary approach to learning that emphasizes your technical skills and builds professional development. The Challenge program is all about project-based learning, and it consists of 4 pillars. Vertically integrated projects, or VIP, are ambitious, long-term, multidisciplinary research teams that are led by a faculty, academic, or researcher. UNSW is actually the only Australian university that's part of the VIP Worldwide Consortium of 37 universities. Earn 6 units of credit as a professional elective when you commit to a VIP team across all 3 terms. The Maker Games, or My Baby, is an AFR award-winning design and prototyping course and competition where student teams solve a challenge submitted by an industry partner. Professional development workshops and guest lectures are offered, and work with companies like Oricon, Accenture, Boral, BAE Systems, New South Wales Health, Australian Water Partnership, and so many more to make your claim as champion of the Maker Games. The Maker Games is available at 6 units of credit across terms 2 and 3, or for 20 days of industrial training. Student projects are when complex project management, collaboration, and innovative technology are brought together by our competitive student project teams. Student projects are available as 15 or 30 days of industrial training. And social impact, last but not least, has a focus on humanitarian engineering initiatives where teams apply sustainable solutions with innovative technology to help solve problems in disadvantaged communities, both in Australia and around the world. Social impact is also available for industrial training days. And here's how you can sign up to the Challenge program and get involved with one of the teams or programs. Here's the QR code here, so give that a scan quickly with your phone, and you should be taken to the project pages where VIP, student projects, and social impact teams will all be available to view. For the Maker Games, those challenges from our industry partners will be released in February. So just before you report in for term 1, all of the approved challenges will be available for you. So yeah, have a look at that, have a go, complete a application or an expression of interest, and hopefully we'll see you next year. Thanks.
let me hop back in because people are asking questions and I don't necessarily have all the answers here. Um, I do work with one of the VIP projects, but that one's a fairly big one that I think at its minimum level is second year students. Um, but I don't know because there's a lot of other projects there than just the VIP that I know. So I think this would be a question that you definitely want to take to the people talking about that. Oh, just for example, for everyone wondering, the question was whether first year students can actually um, take part in things like the challenge programs. And I know there's lots of different kinds of challenge programs, so I can't really answer for it because I only know a bit of how one of them works. Um, so I think you'd have to ask them. But I think there's a lot of things that are definitely open to first year students to work on. All right, back into the lectures now that we're out of the break. Let us continue a little bit with a thing that I'm calling dice statistics. So it's not the same as the dice checker that was doing an individual roll of the dice. We're now looking at the idea of a program that shows me all the different ways that two dice could be rolled. So what I want to do is say that if I have, just grab my dice, two six-sided dice, and I roll them, is there a way for me to know all of the possibilities that those dice can roll? And so now you can see why the example's going like this, right? Because we can see already this is probably going to involve some looping. If I want to see all the possibilities of a die, then I'm going to loop through all the possible values that could be. And then I'm going to say, okay, let's look at some statistics here. If I roll those two dice and I have a particular number I want to roll, can I get a program that tells me what are the chances that I have of rolling that particular number? So if I roll two six-sided dice and I say, okay, I know that one of the values that these things can show is a 7. How many ways can we roll a 7 on these two dice? And what are my chances of rolling that number? So that's the kind of program that I want to make now. Let's think about how we're going to build that. So which program components will we need to make this work? One thing we're going to do is we're going to say, let's have some way of finding all the possible values of two dice. And then we're going to see the possible totals by adding together all the different possible combinations of the dice. And then if we want to find out whether we can make a certain total or not, and what are our chances of making that total, we need to go through and count how many times a particular total has come up in all of the combinations of the dice. So we're going to start small and build up. I think I'm going to skip out of the slides here. Yeah, so the starting of this is going to be reasonably similar to our dice checker that took in information about the two dice. But instead of getting individual rolls, we're going to say, okay, how big are the two dice? And then we're going to loop through them and create all the possibilities. So I'm going to skip out of the slides here and go to, I'm no longer using the loop demo, I'm going to create a new file. So in my lecture 4, I don't have any files at the moment. So to create a new file, I can use the same command I'd use to open a file with gedit. Any other editor you're using should have a way of creating a file as well. I mean, even to the point where I could just click the new button in here. But I'll do it here via command line to keep reminding everyone about how we're using command line. People asking about Discord chats and stuff. Yeah, CSCSOC runs a Discord. I'm actually on that Discord. I'm not going to be on it every day, but I am on that Discord so I can help occasionally. Okay, so we're going to create a new one. I'm going to call it dicestats.c. Oh, I should have put the and on the end of that. I think it's okay. Yeah, it's okay. All right, so we've got a new program here. And I'm going to put some information about what it can do. Finds all possible rolls of two theoretical dice. So I'm going to say theoretical because we're actually going to have more possibilities than physical dice can have in this. Checks how many how many combinations will result in a target number reports percentage chance of rolling that number. What are we? Still September. Oops. Okay, so that's a decent enough. Oh, let me move this so that my face isn't blocking it. So that's a decent enough starting comment. We're going to do our standard program setup that we're going to be using for most things. I know that I'm going to need to print out some information to my user, so I'm going to use the standard input-output library. Int main void, we're getting used to this. This is the standard thing that we're going to see. Return 0 is not always going to be there, but I'm going to have that in there for now. Okay, as we've done before, I showed this at least once before, I have a complete program. Doesn't do anything, but it's complete because I've closed all the brackets that I opened. I'm including the right things and I've got the right keywords. So we could nearly say this section of code, you could copy paste this and use it at the start of every program you're creating for now until we add more details. So you can assume that it's always going to be this, and then we're worried about what code we put into this section here. Obviously this is not going to be the same. That's stuff that we're going to write for each particular thing. So now that we've got all this set up, we're ready to start writing our code ourselves that we're working on. Yep, nope, nothing in chat that I need to look at right now. So first thing we're going to do is take input from the user about the size of the 2 dice. And we had that here in the slides. This is going to look reasonably similar to some of the stuff that we did with just taking input before. So I might need the variables. Die 1 size. Another thing I might do here is I might do some safety coding. So I'm going to set these two, before I do anything with them, I'm going to set these two to values that they kind of can't be. Because the dice size of -1 just sort of doesn't make sense if they're representing something that's physical like this, which means that later on, if I'm using my program and I have -1s in it, the -1 comes back, then I know that something went wrong with the input to these. So I've got a little bit of it's like a safety net there. So if I did something like this and said it's 6, I could get this kind of false positive effect where the program starts running as if it's size 6 even if the input was incorrect. So this will help me. So it's kind of like forcing my program to fail at some point because I give it an illogical number as the first setup before I take in the input. Okay, so to take the input of one of the dice, I would say, please enter the size of the first die. And I might leave it there so that this is going to print out to the user, leave a space, and then they type their number in immediately there. And I will scanf. The type of thing I'm scanning in is an integer, decimal integer, which is %d. Where it is going is into the location of die 1 size. So that should be overriding that -1 with something, assuming this works correctly. And the nice thing is if it didn't work correctly, this thing stays -1 and I'll know there's a problem. I can do the same thing, not exactly the same, for the other die. And I'll scan this one in. Oops. those afterwards. The location of die 2 size. Okay, so at this point, we will have the size of both of the dice that are going to be rolled. Then I'm going to say loop through all values of both dice to get all combinations. I'm going to put this together the same way we did the loop of stars. I'm going to make something easy, and I'm going to put that inside another loop. So the first thing I'm going to do is I'm going to loop through all possible values of the second die. I'm starting with the second die because then I'm going to put a loop around that to say, for every value that the first die can be, by looping through the first die, loop through all values of the second die. But I want to build this up piece by piece that makes it easier for you to understand. So I'm going to loop through die 2's values, which means I'll have an integer. Let's call it die 2 value. I'm not going to be starting at 0 now because I'm simulating dice like this. Dice are going to start at 1 and then go up to their size value. So I'm going to start at the value 1. And this is the nice thing, you know this, right? You know this because we're using the variable names saying value. It's a little bit easier for us to understand that if we're doing that, the variable reminds us of what kind of values it should have. Okay, so if I'm looping through die 2's value, I will then create a while loop. I'm going to just put some white space at the bottom here so I'm programming at the top of my screen. Oh, chickens come to supervise. Make sure I'm doing the right thing. Just like, see a tail. So if a tail flicks me in the face, that means, I think that actually means I'm doing the right thing. Okay, so remember every time we create a loop, we think about how it's going to stop. So if I'm going to be counting up through the die values, I want this thing to run for every value that the die could possibly have. So I'm going to say this is going to run until die 2 value is, and it's still going to run for the maximum value, so I'm going to do less than or equal to die 2 size. So it runs for 1, and it still runs when it equals the same thing as the size. So if it's a 6-sided die, it has the value 6 in it, so we're going to go all the way up to 6. And it's going to run for every value below that. But when it gets to 7, it's not going to run. So we know there it's going to run for each value. And then I need to know how this thing is going to loop. I'm going to show you something new. This was, someone pointed this out earlier. I think it was some random guy. Die 2 value plus plus. Okay, you haven't seen this plus plus before. But let me show you, because I had some slides here for this. Quick pause, some new syntax. Incrementing happens so often that we have a shorthand for it. So we've got this that I was showing you before that we know how to do. We assign the value die 1 plus 1 to die 1. That's just increasing die 1 by 1. If we do a plus plus, that does the same thing. So what I say here, the following 2 lines have the same effect on their variables. So both variables are now 1. So we can add 1 like this, or we can just do the plus plus. Plus plus is going to add 1 to this variable. So it's just a little shorthand that's going to make this thing that's in all of our loops a little bit easier. Plus plus on the end of a variable just says I'm going to add 1 to that variable. Yep, and how you is saying the same thing. But you said die 2 size is -1. Die 2 size was -1 unless we read in a value from our user. So die 2 size here gets scanned in. So what we're hoping for is a valid value from our user. If we didn't get a valid value from our user, then this thing never runs. So we'll know something's wrong if this thing doesn't run because it was -1. Beza is asking a random question. Are we writing in C or C++? Well, it's an interesting question because we are writing in C. And so everything we're doing is C. But C++, as an addition to C, everything that you write in C will run in C++. So if you're ever using C++, you can use C code to run C++. C++ only has things that are extra on top of C. So it's kind of like yes and no. One could technically say we're writing C++, but we're actually focusing on just C, and we're never using any of the extra bits that C++ has. Adam is looking at other shorthands. I will introduce those shorthands as we come. Plus equals is a shorthand to add a certain amount. Minus minus is the same thing as plus plus, but goes downwards instead of upwards. We'll have a look at the plus equals, I think next week or the week after. I'm slowly going to introduce the shorthand bits. Okay, so here I know I'm going to go through, and this will see every value of die 1 from 1 up into, sorry, of die 2 from 1 up into its size. So just to make sure, let's print it out. Die 2 is this. We'll put an end line on the end of that, just to be nice. And we want to print out the values. Okay, let's run this now and just make sure that this loop is working. So this is like, we don't really want to write too much code before we test it. So this is about enough code where I want to see if this loop is working. This is also going to test whether this input was working. We're not testing this input yet because we haven't done anything with it, but at least we're testing something. So, I was pressing up and down looking for my previous compilation command out of instinct, but we don't have one because we only just created this. So to compile dice stats, I tab completed that to make it easier for myself. I'm going to call it dice stats. It's very common that the program name is going to be the same as the C file name. Okay, no errors in compilation. That means that our code is syntactically correct. It doesn't mean it's running correctly yet, but it just means at least what it often means is we can't see the errors that we've made. The errors are different. Anyway, let's run this and see what we get. Okay, size of first die. Let's for the moment just stick with 2 6-sided dice because we're just going to reduce the amount of human confusion or use the dice that we see most often. So 2 6-sided dice. Die 2 is looping through with 6 different values. Okay. This is good. Savesh asking about plus plus A and A plus plus. Yeah, they exist. The only ramifications of those are when they do what they do, but we're not going to talk about that. It's confusing enough that we don't need to talk about that right now. Okay, so I know my loop is working. That loops through all the values of die 2. So what I want to add to that now, oops, I went to the wrong place, here, is, I'm just going to close that because we don't need that anymore. What we're going to do now is we're going to say, if we looped through all of die 2's values, what we want to do now is loop through all of die 1's values, and for every value of die 1, I want to loop through all the values of die 2. And this is the way that we could just say, all right, if we do this, we're going to see all possible rolls of the 2 dice when they're combined together. Actually, I don't need a new one there. Okay, so we've got die 1 value is going to start at 1. So this is going to be a really similar loop, right? Because we're just looping through another die here. So if die 1 value is less than or equal to die 1's size, that's going to loop through. And I'm going to say die 1 value plus plus. So here is my loop that is going to loop through all possible values of die 1. while we're looping through all possible values of die 1, each time we look at a value of die 1, we want to match that up against all the values of die 2. So for example, we have a 1, oh you can't really see it, but we have a 1 on die 1, and we're going to combine that with the numbers 1 through 6 of die 2, and that's some of the possible rolls of the dice. Then we look at the 2 on the first die, all 6 values of the second die. Once we've gone through all of that, we're going to get all possible ways that these two dice could land when they roll. So what I'm going to do is I'm going to loop through die 2's values inside the loop for die 1. So this is why I did the stars example earlier. So it's a very, very similar thing if we want to do a two-dimensional loop. So we're going to paste this in here, and then we're going to indent this to the level of inside this loop. And what I might want to do now is not just see what die 2 is here, but I want to see the values of both the dice. So die 1 is something, and die 2 is something else. So note that die 1 value here is inside this set of curly brackets, so it exists all the way through the loop and past it. Die 2 value is inside this set of curly brackets, so it exists only inside here. But that means that here I can use both variables, because both variables exist at or at a higher level of scope than what we have here. So the first one is die 1, so that's die 1 value, and the second one is die 2. Let's just make sure that I'm not, yep, not too bad. So this way I will be able to print out all the values of each of the dice and all possible combinations. So I'm going to save that, and let's test this to see whether it's doing what we want it to do. DCC, compile this to create the program from our code, and then the / and the program name to actually run the program. Stick with 2 6-sided dice for now. I may actually use some smaller, I'll use some 4-sided dice in a second when I see how much this prints out. 2 6-sided dice, we're double looping here. So what I'm expecting is 36 entries. Let me scroll back up, and I think I'm getting that. 6 values of die 1, 6 times die 1 rolls a 1, and die 2 goes through all its different values. So if die 1 was 1, die 2 can be all the other values. This gives me all possible combinations when die 1 is 1. And then die 1's going through all 6 of its values. And each time it goes through its values, we see all the possible values of die 2. So what we're actually seeing here is this is us counting up all the possible ways that 2 dice can be rolled in combination with each other. So this is exactly statistically correct, the 36 number of ways that you could roll 2 6-sided dice. I was going to do like 4-sided maybe so it all fits on one screen, but I think you still get the idea of what I'm doing here. So what we have then, if I go back, we need all possible values of the 2 dice. We now have that. So we now know all the possible ways that 2 dice can be rolled. And we would like to see all the possible totals of them adding together. So we can definitely do that, where we can have the total instead. I've got some sample code here. But I think it's better if I just work through the code. I actually prefer, like, I leave the code in the slides in case people need to go back and just work from the slides. But I do prefer during the lecture to work on the code without looking at the other code, because then we actually build it, and I will talk through the process of how I'm building it up. Okay, so we have the values of die 1 and die 2. Let's also print out the total. Total is, and the total is going to be die 1 value plus die 2 value. I have a feeling, I haven't done it yet, but I have a feeling I'm probably going to want that in a variable. But for the moment, we'll just print this out. So I'll put the new line here, and I'll take away the new line here and put a space. So what I'm going to be doing is even though these two bits of text are separate print statements, because the new line is on the end of this one, and there's just a space on the end of this one, when this prints out, it should all print out on one line, because this print statement doesn't have a new line to push it to the next line. Similarly here, this print statement doesn't have a new line pushing it to the next line, so that when a user types something in, it will appear on the same line, and then the user themselves will press the enter key as part of the scanf, which will mean that this will appear in another line. Okay, let's run this, and then we'll see the total values getting printed out next to this set of combinations here. So compiling this, and then running it. Let's do two 6-sided dice again. Maybe I should have shrunk one of them, but it's alright. Okay, so now we see all of the possible totals that two dice can get. And that's going to range from 2 to 12. People who have played any games with dice or spent any time with dice will know, or even just basic maths. You should know that if the values are 1 to 6 on either of them, then the total is going to be somewhere between 2 and 12. And here are all the possible values that can come out. If we were to look very closely at these, we would actually see a kind of a statistical distribution of what we're getting here. So that's, where were we? Okay. So let's now try looking at doing this with a target value. So we said, oh wait, there's a question there. Oh, Alex D's getting flashbacks to permutations and combinations and stuff. I'm trying to keep, I mean, like, there's a lot of maths in programming, but I like to think of programming more as applied maths, in that you don't need to understand all the maths to be able to program it. So, Numit was asking why we had the die 1 size equal to -1 and die 2 size equal to -1. So this was me setting the values to something that couldn't possibly work for this program, so that when I scanf into either of these here, we're going to replace those values. But if the scanf didn't work, then these will remain as -1. So they're only -1 as a safety check. If this program runs correctly, that -1 immediately gets overwritten by the scanf. But if it didn't, if this scanf failed, so what if I type in a letter instead of a number or something, then these things stay at -1, and they don't let these while loops run. And if we were to Control-C and check why things aren't working correctly and stuff like that, we'd see it equals -1, and -1 would be a clue to us to say that the scanf didn't work. So that's just something that I'm doing to sort of safety check for myself. You don't necessarily need to do this. I just thought I'd show it to you because it's an interesting way that you can do. You can set up variables that you know, if the program works correctly, it's immediately going to replace that -1 with a correct number. But if this thing's not guaranteed to work, then this thing reminds us that something has gone wrong. Okay, so the next thing we're going to do is have a target value. I'm just going to call this thing target, and I'm actually going to do the same thing. I'm going to set it to -1, but I'm going to immediately replace it with another value. Oh, Leon's saying if we don't scanf, the program won't execute itself. However, scanf will still run even if it doesn't get the right input. Okay, let me just continue to put our target value in. So we're going to printf. Please enter the target value. Same style of thing. We're going to scanf a number into target. So Dan is asking, how is the code working when die 1 value is less than or equal to die1 size. So die1 value is going to start at 1. Die1 size is going to be whatever we scanned in. So when I was running it here, die1 size was 6, because I typed in the number 6, and that sets die1 size to the value 6. So if this is 1 and this is 6, this is why this runs 6 times. So Dan, die1 size is -1 here. And then what value is die1 size after this line runs? Yeah. So when this line runs, die1 size gets set to whatever I type in. Yeah. Yeah, I think you're getting it now, right? So the -1 would tell me that the scanf hadn't worked properly. Yeah. And so then I would see that there's a problem. But if this is read in properly, then it becomes 6. Yeah. So I think that's the same question that who was asking that? Numit was asking the same kind of question there. So hopefully that's giving, yeah, everyone was asking that same thing. So what is this -1 thing? -1 was just a safety net. -1 we're expecting to get replaced immediately. Okay, so if we have a target value, what we can then do is we can start isolating said target value. So we can start saying, I only want to look at the times that the target value is met. So what I can do is I can put an if statement in here, and I can say, you know what I'm going to do? I'm going to need this total to be something. So I'm going to make a new variable in here, and it's going to be inside the scope of this because I only want to know the total of each particular role. I don't want this to last outside of these curly brackets. So the total is going to be equal to die1 value plus die2 value. And that way I can just use total in here. But that's not the only thing I'm going to do with that. After I've calculated the total, Shrey, what happens if I'm an evil user and I enter -1? Yes, then the loop won't execute. But we won't know for sure. We'll still think that that didn't work. So it's not a perfect safety net. There's one hole in the safety net that Shrey just jumped straight through. Anyway, so we have a total here, which is adding the two values together. And so we want to do an if statement here about that total. So if the total of those two dice is the same as the target, now we're saying I want to only print out this information if it was correct. So we're going to grab this code here with Control X and Control V, and we're going to tab this in. So now what we're going to say is, if they were the same, then print out the combination that led to that. So if we run this again now, we will have isolated only the combinations that lead to a particular total we're looking for. So let's compile this and run this, and I'll show you how this works. What I've done, let me go back to this for a second. What I've done is I say we're not printing out everything. We're only going to print out if the total and the target are the same. So we're going to add together these totals. Leo's asking, if I code die1 size, die2 size, and target to 0, would that work? It'll work. So that way you'll still get some information. You can still say, if this was 0, it means that these things didn't read properly, or the user typed in 0 for some reason, right? It doesn't make sense for the user typing in 0. So you get the same thing. I could also type -55 or something, you know? So I could use a number that's completely off the books in a sense, in order for me to really recognize when something's going wrong. I might just leave this like this, actually. -55 might work. And also, you're saying 0 there, Leo, that will also work. Because what we're really saying is that this is the value that I'm sort of going to know meant that things went wrong. And so long as it's not one of the values where this thing could run, it shouldn't cause the program to work badly. Yeah, David's saying, yeah, -2 to the power of 32. Let's go for absolute minimum value number. That you could do that as well. Tiffany's asking what the plus plus is. So the plus plus, I'll show you, I'll go back to the slide. Here, plus plus does the same thing as +1. So all the plus plus is doing is increasing the value of that variable by 1. So what we're getting is this loop here, when it finishes, it adds 1. This loop here, when it finishes, it adds 1. So that means that every time we construct the loop, just before it finishes, it says move on to the next value. Yeah, oh, other people are answering that as well. Okay, so let's say 2 6-sided dice, and the target value I'm looking for is 7. 7 is a standard number to roll on 2 dice. You've ever heard of lucky sevens? It's old craps thing. That's like an old casino game from the 20s, I think. Here we have all the possible ways that we could roll 7 on 2 dice. So we now no longer have the whole list. We only have things that total 7. 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. Basic maths, adding these together, this looks right to me. William is asking, how would we go about counting how many times that we've rolled the dice? How many total possible combinations? You know what? That's actually something that we want to do right now. Because, let's go back to our questions for what we were supposed to do. If I pick a number, tell me all the ways those 2 dice can reach that total. We're doing that now. Tell me what the odds are of rolling that number. To calculate the odds, we want to say, what are all the number of possibilities? And how many of those possibilities are the ones that are correct for us? So, what we want to do now, I think we're up to here. Oh, no, we're not. Oh, yeah, we're up to here. Let's start counting how many times things have happened. In order to count something, so I want values to exist after the loops are finished, and they're going to total up things. So in order to total things up, I need the variables to exist in a scope that still exists here, which means the scope is going to be the program, not inside any of the loops. So I'm going to make 2 new integers here. In fact, let me put them before this one, because that's the looping variable. Hang on. That goes there. I'm going to put them here. So I'm going to have the total number of rolls, and that's going to start at 0, because I'm going to use a variable that counts how many times we rolled all the dice. So I know with the 6s, this is going to be 36, because I've worked this out. I kind of know that 6 times 6 is 36, but what I want to do is my program to know this. So it's going to count the number of rolls, but I also want to count the number of times we hit the target. So number of targets, I'm going to call that. Both of those are going to start at 0 because we haven't rolled any dice yet. But every time we roll the dice, number of rolls is going to increase. Every time we meet the target, number of targets is going to increase. And then at the end, we're going to be able to see what those values ended up. And so I'm going to put a print statement in here to let us know we have possible rolls, a certain number of them matched the target. The first one is going to be the number of rolls. The second one is going to be the number of targets. I'm getting a little bit too far there for people to see that. These variables are going to get lost, so I'm going to push that down. And what I'm going to do is I'm going to set up this print statement the same way I would a while loop and indent what's inside of it, like so. So that way, when I'm reading this, I go, okay, there's a printf and it's got these 2 variables in it. It's easier than having to scroll left and right to look for these variables. Okay, so what I have is variables here that are starting at 0. Now these ones are not like these, that we could start at any number. These specifically start at 0 because they're counting how many rolls have happened and how many times we've matched the targets. So if we haven't rolled any dice yet, this is definitely 0, because we have rolled 0 times and we've met the target 0 times. Now in here, every time we complete a roll, which is inside this loop, if we have a total, we've completed a roll. So I can say the number of rolls goes up by 1 because we've rolled the 2 dice. But then I say if we've met the target, so inside this if statement, we know we've met the target. So the number of targets goes up by 1. So this is not the same as these. These are these mechanical counters that are going to happen every time. These ones only happen when we meet certain conditions. So this one goes up when we know we've rolled 2 dice together. This one goes up when we know that the total has matched the target. And so we're going to get 2 numbers now. We're going to get one number that says how many times the total we've rolled, and we're going to get another number that says how many times did we match the target value. Johan is asking, will die 1 size multiplied by die 2 size work as well? Yeah, because we know, theoretically, because we know the theory of the dice and stuff like that, that we didn't necessarily need to come through and add this one up. We could have just said, I know that this loop and this loop means we're multiplying the 2 numbers together. So we could just say num rolls equals multiply those 2. But I want to show you going through looping and doing stuff. So I want to show you the mechanics of the code. So I'm going to do it in here. Okay. Let us try this now, and we should hopefully get the values that we want out of here. So compile this and run it. I'm going to use 6, 6, and 7 again because, as David's pointing out there, 7 is the average for rolling 2 dice and adding them together. So we get our same result there. These are the possible ways that we can roll 7s. We have 36 possible rolls, and 6 of them match the target. Cool. Okay, so we know there's 6 of them there, counting up. This means that if we just do some like basic maths, we could say that there is a certain percentage chance that we'll roll a 7. Just to show you an example, we can do this with a different number. So 6 and 6, let's try to roll the number 4. There are 3 ways to roll a number 4, because that's the number of possible rolls of the dice that can add up to 4. So there's actually fewer ways to roll a 4 than there are to roll a 7 on 2 dice. We don't need to go into the maths of how the dice work or anything, because we're just simply counting these up. And so now the next thing that we want to do, because that was the goal of the program, is to take these numbers and say, all right, give us a percentage. So the final goal of the program, I'm going to put some comments in here. Actually, I don't really need the comment there because heaps of this stuff is in English text anyway. But I'm going to say this anyway. Calculate the odds. Wait, I'm not going to say odds. I'm going to say percentage chance to be really specific. Giracha. Inner villain in me. He said the inner villain in me wants to roll a dice and have it land on an edge. Because physically that's technically possible that your dice are what we call cocked, where they haven't landed properly, and it's like then they have no value. And then everything is weird. Yeah. When you threw your yes, no rubber and got maybe. Yeah. Okay, we're not going for that at the moment. We're simulating a world where all of the possibilities of physics are not necessarily there. We just have this theoretical thing. Okay, so percentage chance of rolling a target, not too bad. Okay, so let's just say int chance is equal to number of times we hit the target divided by the number of rolls. Let's put that in brackets because we want a percentage. We'll times that by 100. Okay, if you know the problem, don't say it yet. If you know the problem, don't say it. Because Okay, yeah, this is this funny thing that I always like love to talk about. It's like I don't know if you ever went to those little theater shows when you were a kid, the little pantomime shows, where like the heroes are strutting along through the forest and stuff, and then like the villain pops up out of the set behind them, and all the kids are like, "He's behind you! He's behind you!" And the heroes are like, "No, there's no problem. We're just strutting along here. Everything's fine." That's what I'm doing here. So if you want to, you can yell out, "He's behind you," if you want to. Because there may be a problem with what I'm doing here, but I want to show this first before I show you how to fix it. Okay, so we have our chance here, which is our percentage chance. And then I'm going to do another printf. And I'm going to say chance of rolling the target value is, and it's going to be a decimal integer. We'll put a new line at the end of that, and we'll say chance. Okay, so everybody's like, ah. Okay, well, good. I'm glad that some of you are noticing. If you're not noticing, don't worry. I will show you what's going on. Okay, so I've got my percentage chance here, which is the number of times it succeeded divided by the total number of rolls. So that's going to be our fraction. That's good. Multiply that by 100, we get our percentage chance. We print that out. Let us now run this, and this will be our complete program that will tell us the chances of rolling particular numbers. So I'm going to compile this again. Oh, let me make sure I saved that. Did I save that? Yes, I saved it. Compile that. Run it. Please enter the size of the first die. Now, for the purposes of our testing, I'm going to keep this with 6-sided dice. You could obviously change the size of the dice. 2 6-sided dice. Let's try to get a 7. 6 times out of 36, we got this. The chance of rolling the target value is 0. That's not true, because we got it 6 times out of 36. There should be some chance. Let's try this with a different value. Let's try it with 2 6-sided dice. Let's try to roll an 8. There are 5 ways to do this. The chance is 0. What's happening? Okay. Good. People are seeing what's going on here. If you haven't seen what's going on, the issue here is that somewhere this chance is equal to 0. Now, why would this possibly be equal to 0? So we've got this that we're calculating times by 100. Times by 100 is not going to change anything, because 0 times by 100 is still 0. But and we know that these two are correct, because we can see that they're outputting correctly. So if we look for our needle in a haystack and narrow this down, it's somewhere in here. Now, declaring an integer is not going to change its value so much, so it has to be somewhere in here. And we start to think, yes, yeah, people are people are seeing the problem here. Yeah, everyone's seeing it now. 2 integers divided by each other are going to equal an integer, which means that anything that is a fraction, and all of these are going to be a fraction between 0 and 1, well, if everything was correct up here, this is going to be a value between 0 and 1, somewhere in between. We're going to lose the fraction and we're only going to get the 0. So we'll have a remainder, but we won't ever see it. So the problem is that both of these are integers. We would need to make one of these into a double to make this work. So I've got a couple of different ways I could do this. I could do something like this. Double rolls is equal to num rolls. So I could do something like this that says, let's make a temporary double that is going to be the same value as that. So I'm going to put the integer value into the double to make it into a double. And then what that's going to do is, if I use rolls here, that's going to mean that because one of these was a double, the result is going to be a double. But I actually have a better trick than that. It's slightly dodgy, but it's pretty funny. So let's put this back to num rolls. I'm just going to put this one in brackets. That's it. It's slightly dodgy, but the result of this thing that I have in brackets here is multiplying an integer by a double is going to make this thing in brackets a double. So it's slightly dodgy, but it does work. This is now a double, and if I divide a double by an integer, I get a double. So I get a floating point result. it's, it always makes me feel a little bit like kind of like really kind of smart, but also stupid at the same time when I do this. But it does work. Okay, let's try running this because we are out of time for the lecture. So I'm going to compile this again, and I'm going to run it and go 6, 6, and 7. Ooh, we have 36 possible rolls. 6 of them match the target. Chance of rolling the target value is 16. I would potentially think that maybe this percentage chance should also be a double. And this should be a long floating point number. Because I was dropping some of my percentage points there. So let's try that again. Compile that. And run it. And we'll do the 6 and the 6 and the 7 again because we're not too worried about the values. We just want the result to work. All right, now we're getting a very accurate percentage value. Okay. Uh, Let me just wrap up there. We have some questions, but I'll save them to afterwards because I've already gone over time. So, output the percentage, the problem. So I've already stepped through all this stuff, and there's my multiplied by 1.0. Okay, so now we have a program that can do this, but the question is, did we actually need to do all this? And one of these has already been hinted, is that we could have multiplied those numbers instead of counting them. There are other things that we could do to simplify this based on what we know of maths. So that's a challenge if you want to. You can figure out if you could get this program to do the same thing with less work. So that's where we're at today. I will wrap up there. We have learnt about looping. So we've learnt some of the basic loops. Single pass through a certain number of things, or keep looping until something happens. And then we've used them, so we've got the demo code. I will upload the demo code that we changed, as well as the dice stats code. And then what we've created here is something that is able to use multiple looping to extract a whole bunch of information from code. Okay, so I will um, I will stop here and end the lecture here. Sorry, I went 3 minutes. I always do this tiny bit over time just because I want to talk about this a little bit more at the end. So we're going to end the lecture here. If you would like to ask some questions, I know there's some questions there. So people are probably going to want to pick at some of the detail here. We'll do that after the lecture. So I will stop now, have a quick break, come back and answer all your questions. Thanks all. And I will turn off my microphone. My microphone was off. I'm back. Hello, everyone. I'm back. Um, so what was I gonna say? I'm sure that people have some questions about this code because there's a lot of fiddly stuff there. Um, oh, Shrey. Hi, Shrey. I'm back and you're fired. Okay, yes, you are. He knew he was fired. Okay, so Lynn's asking, can I combine and or operators in one particular statement? Yes, you can. Let me hop back into where are they? Mark's lecture slides. Where did I have it? This one or this one? This one. Back in variables conditions, um, I showed some examples of combining um, things together, like so. So we can have. Oh wait! No, this doesn't have the full combination that you're asking about there. You're asking about combining uh, ands and ors in the same string of things. There are some subtleties to how we would do that, but it is possible. So if I don't know if I want to do it in this file, but let's say we had something else. Let's say we said if um, let's say if the dice are the same size, uh, and or something. I'm just trying to like make up an example on the fly. So if we have die 1 size is equal to die 2 size, and um, num rolls is equal to num targets, which is actually possible, I think, if you have one-sided dice. Um, if it's that and that, or, so we're asking about whether we can combine these things together, that and that, or, what other values do we... I'm just making this up because it doesn't have any particular meaning. Um, target? We've used... Yeah, okay. Or the target is equal to 1. Let's just say, for example, can we... The question was, can we combine multiples of these things together? Yes, we can. So what's going to happen when we have a really, really complicated question like this is this thing's usually going to process left to right. So it will start here and it will go, okay, there's an and, which means I need to process both sides of the and it will start from the left side. There is actually an order of precedence. If you look up, we could actually look this up. Where are we? C order of operations, I guess. I think it was, yeah, precedence. These are the order that things are going to work in. So there's a bunch of this stuff that's going to happen. But if we look in here, we know that the equals and the not equals and the relational operators, all of these are going to happen first before the ands and the ors. And the ands will be done before the ors. So if we go through here and we say, in order of precedence, this thing will be checked first and it'll be given a value. This thing will then be checked and given a value. This thing will then be checked and given a value. Then this will run, which means we will get the result of this. And then this will run, which means that we will get a result of the OR of this side and this side. So they will all come together like that. So in the end, the final thing will be the OR that says, did all of this stuff get a 1 or a 0 versus all of this stuff. The way that C works as well is if it gets a final result quickly, it won't actually check the other side. So the interesting thing is it will do this first. If this is a 1, then the OR is correct. It will never actually look at the other side because the OR only needs either side to work. Oh, you got to go teach class, Trey. Yeah, see ya. I assume. Oh wait, I can't remember when Trey is scheduled. He might be teaching a 151 class or going to another class. Yeah. So this big combination using ands and ors will still work, and what C will do is we'll break it down into its parts. So it'll do the simple things first, like these tests, this test, and then it will combine the two of them together. And because it's an and, both of these have to be true for this to be true. Or if this one is false, then the whole thing is false. But if this one's true and then this one is false, the whole thing is false. So it will calculate that, and then it will have a 0 or 1 value for this side of the OR. And it will say, okay, given the two sides of the OR, is the OR true or false? And then it will go through. So it's going to piece together all of this bit by bit. Yeah. Did you expect that the answer was going to be that complicated? Yeah. But the short answer to your question is, yeah, totally, it does work. But again, it's an interesting thing, and this is something that I always kind of think about when we're working with computers in general, is that computers are like brains that think in a particular way, and they think in a different way than humans. So the computer's going to be okay with this. But are we? So for me, the question is, am I okay with this? It's like, yeah, I guess so. I'd have to look at it carefully and know what I'm asking. I'd want good variable names so I know what's going on here, and then I can understand it. But if it gets too much more complex than this, I might split it into multiple statements. I might say, if this, do this, else if this, do this, and stuff, depending on whether that works. I mean, sometimes I've had if statements go over multiple lines. It's a bit dangerous because you can do this if you want to. You could just reorganize this and stuff and put this down here. You can put that there. It gets messy, but you could have if all of these possible conditions are combined together to be correct, then run this if statement. But I would never do something with this much stuff in it without saying something here about why are we in this if statement. That way someone can say, oops, clicked on the wrong thing. Someone can look at this and say, oh, that's too much. I don't get it. Can you explain? So I would say something here that explained it. Yeah. Yeah, Josh is also saying probably best we just use some brackets. Yeah. Sometimes the questions are so big that you do need to ask it. But if you do, please explain something, because otherwise you're going to be in a bit of trouble there. I think that bracket was part of the if statement. Okay. Dan, can you show a way to solve the word addition in a more efficient way? It took me half an hour of writing repetitive code. Yes, but also not all the tutes have run. So I don't want to give answers to things before all the tutes have run. However, let me give you one hint. So if we're looking at different branching code, so we do if this, then else if this, and then inside that if something else, and inside that if something else, and then at the end we print out one statement. Then we're doing a big branching thing, and at the end we have all the different possibilities. But what we could potentially do is print out part of the statement based on some conditions, and then open up a different set of if statements for other conditions. So the simplest thing I would say for something like word addition is if you've got positive or negative, check for that first, and then check for the values in a separate set of if statements. So that way, what I've just done then is I've got 20 possible values, right? Because I think it's positive 10 to minus 10. But I've checked for positive or negative first. If I've checked for positive or negative first, then I'm only checking 10 numbers after that. So I've got one thing that flips between two possibilities, and then the 10 things. That's one thing that I could do. I shouldn't have said that. That's probably too much. That's more information than you should have had. In the same way that I loop through here, but I'm only writing the code once for printing out the total. So instead of doing this 36 times, I'm doing it once. But the way you do that with if statements in a challenge is slightly different. So I don't want to say any more because it's going to ruin it for people who haven't started it yet because their lab is on this afternoon. Okay, JD is asking, could I quickly explain? Let me just check if there are any other questions there. Oh, Josh was asking, can we use brackets double in the example before we multiplied by 1? Yes, we can. There is another thing that we can do called casting, and I wasn't going to talk about it because it's not necessary for anything that we do in 1511. So I didn't want to introduce a concept that was not going to lead anywhere in particular. But you can actually, if the value is allowed to work with a different variable type, you can actually put, so I'll do it for this one. You can actually put the variable type in brackets before something, and it says, just for right now, as we're using it, treat this thing as one of these instead of what it actually is. You would have seen this potentially in other programming languages where you say, I want this thing to look like it's a different type than it is. And that would work here as well. So if we took out the multiplied by 1.0 there, we could do this. I did the multiply by 1.0 because what I wanted to do was use something that is only what I've taught already. So it's a bit of devilish trickery that that doesn't have to introduce any new concepts. You just use the concepts that we have, and it slightly changes what we're doing. Okay, JD's question was, explain the loop in loop star example again and how it operates. Okay, let's go back to that. I'm just going to open the other file. So the way that I put this together was, before I put it inside this loop, I had this. So let's pull it out again. So initially this was the only code I was using. So if this is the only code that I've written, ignore everything that's up here. This is a loop. Let me just put that back in its correct indentation. That says we start at 0 for stars, and we keep running stars until stars is equal to 10, which means if it's 0 and less than 10, we know that this loop will run exactly 10 times if we have a +1 here. So if I know this runs exactly 10 times, this action or this code that is inside the while loop will run exactly 10 times, which is printing 10 stars. So let me comment out everything else. I wonder if I've commented out everything. Yeah. It's called loop demo, I think. Loopdemo.c, and the output file was also called loop demo. Okay, so if I run loop demo now, did I not compile that? Did I not save it? There we go. I'll save it, compile it. I wonder if everyone can notice that, like, I have this like full-on brain intensity for 2 hours during the lecture, and the second we go to question time, my brain just goes, it gets a bit mushier. So it's like simple mistakes by not saving stuff. Okay, so I run loop demo now. I get these 10 stars, and I get a new line. I know that I've got a new line because this prompt moved down to the next line. So let's look at what happened there. We printed 10 stars inside the loop. And we know that this loop ran 10 times because it went from 0 and it had +1 each time and then ended up at 10. So that's what we got there. We got the stars. And then when we were finished printing those stars, We then also printed an enter at the end, which moved us down to the next line. So this is one piece of code. So we have this one piece of code that uses a loop to draw a line of stars. So if I want to draw a grid of stars, what I want to do is I want to run this code multiple times. So if I want to run this line drawing code multiple times, the easiest thing I can do to run the same code multiple times is to put it in a loop. Now, if I wanted to be really silly about this, I do this. I could Control C, copy, and then paste. 5, 6, 7, 8, 9. That should paste that 10 times. This will probably draw that grid. Actually, it won't, because I've got this problem here that I'm redeclaring the same variable. But something like that, I did actually just copy paste that multiple times, would be the way that we would draw multiple lines. I'm going to Control Z, undo this, because I don't like having multiple copies of the code. Also, it doesn't actually run, because you can't create the same variable more than once. But instead of doing something that silly, and copy and pasting the same code multiple times, what I want to do is I want to loop it multiple times. So I'm going to create another loop. And this is the number of lines I want to draw. This happens to also be 10. But I could change those different numbers. So let me say I want 5 lines, and each line has 10 stars in it. So I would like the code to draw a line to go inside this loop. And this loop's going to run 5 times. The code to draw a line is here. This is the loop that draws 10 stars. And we've already seen that working here. It draws the 10 stars by looping through 10 times and doing printf of that 10 times. So if I Control X to cut that, Control V to paste it in here, I'm going to fix up my indenting because it's inside this while loop, so it goes indented like that. This means that this loop here is going to run 5 times, and each time it runs, this thing's going to print out 10 stars. So what I should get now is 5 rows of 10 stars. So I'm going to save this, compile and run this. So compile there, run it. 5 lines, each with 10 stars. So we have the 10 stars. I'm just going to say 5 times there. So the way we think about it is we had this code here to draw a line of 10 stars. And then we had this code outside of that that says how many times did we want to run this code. 5 times, we get 5 lines of 10. Okay, cool. Hopefully that helps. I will have this code saved, and I'll upload it to the lecture section so you can grab it if you want. I probably won't uncomment this bit here because that will cause problems. Okay, Kat is asking, is there a way of making words equivalent to a number in the same way that we can do double value 2 equals value 1 where value 1 is an int? So the only reason that we can put an integer value into a double or a double value into an integer is that they're both clearly numerical values. If we wanted to convert a word into a number, there would have to be some clear numerical value that we could use. And because if words make up numbers, they're very, very complicated in the way they make up numbers, there's nothing automatic that does that. You would have to read it and test it, which is exactly what word addition is asking you to do, is to actually come up with the code to do that. So unfortunately, there's no automatic way of doing that. There is actually an automatic way of making individual letters into numbers, but we're not up to that point in the course yet, so word addition is not actually asking you that. So there's a way of counting letters as if they're a code for a number, not a code for a letter, not an actual letter. So unfortunately, there's no way, Kat, that you can do that without having to kind of work on it yourself. Lynn's asking how to calculate 4 space indentations that are required in style. So I think what you're saying is how do we make sure that we get 4 space indentations? If you're using gedit, with 1511 setup. So I've run, let me just run here, 1511 setup. This is going to go through and set up all the defaults for gedit. Every time I press tab, it's going to put 4 spaces in. Any text editor that you're using that's a code text editor is able to do indentations, and so you can probably make it so that the 4 spaces will work like that. I'm not sure if that's exactly what you're asking, but it's something like that. So Eric is asking, do we need both the double chance at the start as well as a way of turning the inside bit into doubles, like the times 1.0? So Eric is asking about dice stats here. So we have several different places here that variables are being used. This one's being created. This one's being kind of converted. This one's still an integer. So we've got an integer, and a double. If this was all integers, this would still be a double, but the value that it would get from here wouldn't have, it would be a 0.0, because an integer doesn't have any fractional values. So what we'd get in here is something 0.0. But if this side is a floating point number, sorry, been working with too many other programming languages where they're called different names. If this is a double, a floating point number, then the whole value gets put in there, whatever it is. The fractional value goes across. If we take this out and we just do this, then this still is going to be equal to 0. So these two integers are going to create another integer, which is 0 times by 100, still 0. And it doesn't matter that this one is a double. It's still going to take on whatever value it's given from here, which is going to be 0. So we've got one issue of the division of integers losing some precision, losing kind of all of their precision, versus this double here. So if I put this back, the difference here is I could make this a double or an integer. If I make it an integer, it loses whatever decimal places that this thing created. But if I make it a double, it retains all of the precision. So if this is an integer, then the percentage will be close to correct to 1 percentage point lower than what it is. If I make it a double, it's much closer to the correct percentage. So if I wonder if we've still got it here. This was percentage being an integer, and this was percentage being a double. This is more precise. So we got better precision here because we retained everything in the division calculation, as opposed to when percent, this is if chance was an integer, it just dropped the 0.66 there in that one. So this is after we changed chance to a double. Okay. Beza is asking, phew, just got here after trying to catch up on the live stream by playbacking at 1.5 speed. I think that's really one of the funniest things about doing online lectures is if you turn up late, you don't technically miss anything. You could just speed up and you could still get to the finish at the same time as everyone else. If you have any questions, Beza, feel free to ask. Kevin, you have been on ×2. So is it like people turning up an hour late and then going at double speed or something? I guess you can totally do that if you want. My rapping is going to be so awesome at double speed. I'm like, who's the guy that really... Busta Rhymes. I'm like Busta Rhymes, just rapping so fast no one else can keep up, right? Anyway. Okay, JD's saying, so do I think of the one line equals a star loop and then I loop line 10 times? Yes, you can think of it that way. It works really well. The other way you could think of it is it's a two-dimensional grid of things, and one of them moves you down a line and the other moves you across. And so the inner loop moves you across and the outer loop moves you down once the inner loop is finished. So you go there, the inner loop finishes its thing. When it's done, you go down, and that's the outer loop moving once, inner loop moves multiple times, outer loop moves one, inner loop moves. You can think of it both ways, but I think that conceptually it's easier to say I have a loop that does something, and then I stop thinking of it as a loop. I think of it as a piece of code that does something, and then I run that piece of code multiple times. Okay, cool. So Kat's got some information there, Lynn's got some information, Eric's got some information. This is good, this is working. Um, yeah. All right. Alfred has a question. Did we expect to explain how the Easter program work of the last challenge? So I won't be explaining in lectures, because actually maybe next week if people want to. Like I don't want to explain it when people haven't had a chance to do it yet. But you have the kind of I'll give you some hints at least. So we have the leap year exercise, which is to determine whether something is a leap year or not. So that's using a bunch of calendar information to figure out when something will happen or how something will happen. Easter is the same kind of question, but a lot harder. So Easter says, um, I think it's like what day of the week Easter is on, and so you've got to do these calculations based on knowing when Easter was at one particular point in our calendar and being able to like move through the calendar in either direction. Maybe you're going to use mods to figure out the difference between the number of days in a year and the number of days in a week, and then to find out which one it lands on. Um, but I'm not going to give you any more information than that. I'll let you play around with it for a bit. And if you want to, play around with it for a while. See if you can figure out a procedure that you want to follow to find out what day of the week Easter is on. Because that is enough to get you thinking about the problem to say, okay, there's a bunch of stuff we can do with programming to figure out whether this is going to work or not, or how this is going to work. And then you can go, okay, now I'll translate that into. And so you can do a lot of stuff by hand by thinking about um, how you want to approach the problem. Because the Easter one's a hard problem. It's not actually as hard as some of the other stuff we've got later in the challenges, but it is still a hard problem. One thing that I would potentially do for that is similar to the leap year. You've got some information online on Wikipedia and stuff like that that says how do we calculate this stuff. Um, Given that you have some knowledge of how to calculate that stuff, um, see if you can apply it. The way that I would break that down first is to say, um, what day is, I think Easter is like, what day is a particular day of Easter going to be, like Easter Friday or Saturday. I can't remember what the exact question is. But you could say, can you figure out what day Easter is on next year? That's an easier version of the problem. And this is how I often approach a lot of difficult programming things, is I say, if this question was easier than it was, how would I solve it? And I solve it and I learn a lot about the question. And then I say, okay, now that I've solved that easy thing, can I now make this answer more of the question? So something, you'll see how I do this, right? I did this very intentionally today with dice stats where I said, I'm not going to go through both dice at once. Let me look at all the values of one die. And that was my loop, and I printed that out and I was like, okay, cool. This gives me some information about how I'm going to solve the problem. If I'm looping through all the values of one die, and I put that inside another loop that loops through all the values of the other die, they're going to multiply and they're going to give me all possible values. I didn't really need to know about the theory of combinatorial mathematics or anything like that to be able to do that. I just knew that if I was going to roll all of one and all of the other, then I could put those inside loops. That's why sometimes, I talk about computing as applied mathematics, in that we don't have to understand all the maths. Sometimes we can do it procedurally, which is like C is actually called a procedural language, where we say, I don't know the theory, but what I do know is how to just look at all the possibilities. And as a human, it's really difficult to look at all the possibilities. It's really cumbersome. But to get a computer to do it, a computer mechanically can do it really quickly. So this is why sometimes we do things in this way, where we don't necessarily go to the full theoretical mathematical level of it, which I could have done. This code would have looked completely different if this was a mathematics programming course. There is no way we would have done this bit, number of rolls here. We would have taken the advice that someone said in chat, which was just multiply the values of the two dice together and you'll get the total possible number of rolls. That requires some knowledge of the theory. I've done this without knowledge of the theory. I've just said, I got a computer that does several bajillion operations per second. I'm just going to get it to do it. I'm just going to, why am I counting? Why am I thinking about what's going on? I'm just going to get a computer to do my thinking, which is what? I mean, I don't want to belittle computer science too much because it's like my entire profession, but that's what we do, right? Um, if we have an amazing calculating machine and we want it to deal with the problems it sees, then we'll get it to do the counting. Yeah. Jack is saying bashing is easy, systematically enumerating is hard. Yeah. So, um, a lot of the time when we're doing solving programming problems, there's an elegant solution to the problem. And an elegant solution would have been just to multiply those numbers together. There, die 1 size and die 2 size here. But what I will often do is what's called the brute force approach, which is you just get the code to do the thing. You get the code to do the thing in the simplest way possible first. It gives you a good understanding of the problem, and then if you want to make it work better later, you can fiddle with it. So a lot of the time when we're trying to dig out difficult problems, it's a matter of just sort of looking at things from a simpler perspective first before trying to get too complicated. Code's complicated enough as it is. Oh, cat. Imagine programming a quantum. You can, by the way. It doesn't run on a quantum computer because the number of physical quantum computers in the world, like, I don't know. I don't know how many there are. I think you can count them on two hands, but there's probably more than that now. I know UNSW has one, or even more than one, because I know that they're working on different materials to store the qubits. But I think they've actually got it to the point where this thing fits in one room. It's usually because it has like massive cryogenic cooling to make it work. And they have some of the bits that actually hold their state for a few seconds, which is actually remarkable because these things are like on a physical level they're really difficult to do. So we take it for granted that our computer will hold the state of the bits that's in it for, um, you know, a whole day until we turn it off, and then it turns off. Quantum computers haven't reached that level yet. But quantum computing is really interesting because this here that we looped through all the possible values and we had to do them one at a time, quantum computing would say these two variables have all of these possible values, and they are in all of those possible values at once, and then we'd analyze everything at once in one step rather than this 36 steps that we were going through here. Yeah, it's super cool. We're not going to go too deep into that. But yeah, there are quantum computer simulators that you can program on, so you can actually learn. I remember who was doing it? Could have been IBM or Google or Amazon. It's one of those giant tech companies. But you can look up quantum simulator, and they have particular ways of programming with these where instead of looping through everything like this, you just go, this has these possible values, and you can assess all the possible values in one step. So super interesting. And when quantum computers become stable enough for regular use, there are a bunch of there's a particular class of programming problems that will go from having to take, months or years to process to processing instantly, and that'll be really interesting to see where that happens and what it shakes up. Okay, I think I've answered all the questions for today. Thank you for sticking around, everyone who is interested in all the little bits and pieces at the end. I will sign off here, and I'll see everyone on Tuesday. Oh, I've got to remember, I have to put a notice out. There's going to be uh, an outage of our computing services over the weekend at some point. I've just got to make sure exactly when that is, and I'll let you know. Which means that stuff like VLab won't run for a few hours on, I think it's Sunday, but we'll see. We'll see where it is. So actually, that's around the time that I usually send my notice out. So I'll make sure I send out a notice this afternoon, letting you know when that's going to be. All right. Thanks all. See you soon.